I hope that you're here for the Detecting Complex Code Patterns Using Semantic Grep talk. Welcome to the first of the OWASP Toronto May 2020 talks. We have with us, as I mentioned, Drew Dennison, who is going to talk to us today about this, and from R2C. Just a couple of housekeeping notes before we do start. You should see in the video description for this particular talk on the YouTube channel, the regular OWASP feedback form. So we use this to get your feedback about events, about what you want to see, about how well or not well the format worked, and so on and so forth. We also use it right now in case you want to claim CPE credits. We kind of need a little bit of proof that you came to the event, so please leave your email address and your full name in the feedback form so that we can definitively say when we are asked that you did attend the event. We also have in the description R2C's feedback form. So this is Drew asking for, feedback about his content, about his speaking style, about those types of things. And he's generously provided us a link to his slides. This talk will also be recorded, so you can come back to it later if you happen to miss little pieces, or if you feel like, hey, this is something I would love to share with other people. Drew has given us permission to share it with some of our other community friends, so that's great. A little note that he asked us to mention is that R2C is hiring security folks. So if you want to reach out to him and talk to him, you can use his feedback form to ask him questions and to talk to him about potentially working for him. So I did say that this was the first of the May 2020 events. We will be having Ellie from Synopsys again here on the 20th, and he'll be talking about the basics of starting software security programs and how to measure the success when you do. So hope to see you then. The last couple of things is that you do hopefully have access to the live chat. We'll be taking questions through the live stream. There are a couple of places in the talk where there will be some pauses for Drew to take questions. And so Yokve will keep track, and the rest of us volunteers will keep track of what's going on in terms of questions, and we'll read them out to Drew and he'll answer them. Okay, so that's all I have in terms of housekeeping, which means we can now hand it over to Drew.
Thanks so much. Great to be with everyone tonight. So as was introduced, I'm Drew. This is my Twitter handle, and the slides are below. So feel free to go there. I'll just leave this up for a second, and it's a pretty informal talk. So like I said, I'll stop and take questions throughout the talk, but feel free to interrupt or save questions to the end. Either way works great for me. So if you're trying to decide, like, hey, should I stick around for this talk? To give you just a quick overview of what we're going to talk about. So writing secure code is hard. I think security is shifting towards code. So if you're considering a career in security, I think this could be potentially interesting for you. And then the primary reason we're going to talk about is this new open source tool, sgrep, that we've recently made available to the world. And so I'm excited to show you how to use that. But before I do that, I'll just quickly introduce myself. So I'm Drew. I'm one of the co-founders of R2C. R2C is a small static analysis and security company based out of San Francisco. I got my bachelor's in computer science from MIT, and I worked at Palantir, which is a large commercial consulting firm prior to starting R2C. I grew up in Chicago, and then I spent some time in Boston, and now I live in San Francisco. So I feel lucky to live in 3 of the great cities of the world. What I enjoy doing when I'm not having to stay inside because of COVID is sailing on the bay. So I'm looking forward to getting back out there on the water, and I hope to sail near Toronto sometime in the future. I was looking through my Google Photos earlier today. I'm trying to remember when the last time I was in Toronto, and I found this stomach churning view from the top of the CN Tower, which I had a lot of fun too. I think that was last year I went and visited. So Toronto's awesome. Hope to visit again soon. All right, so just to give you a brief outline of the talk, as I mentioned, we'll kind of talk about how hard it is to write secure code, talk about sgrep. I'll give you a tutorial kind of getting started and show you how you can follow along. And then I'll just leave with some closing thoughts about how you might use it yourself going forward. So this is an OWASP meetup. So I'm sure most of you are familiar with the concept of the OWASP top 10 list. It's kind of the industry standard for what it means to write, secure applications. And we don't have time to go through all of them in detail, but generally a big fan of the OWASP top 10 list. And I recently learned that there's a new OWASP top 10 for APIs, which I think is really great because the era where you're writing kind of monolithic web apps that are server-side rendered, a lot of things have changed now. You have microservices, you have single page, React or Vue.js apps. So I'm excited to see this new list get put together. And most of the things we'll talk about will fit into one of those categories. But if you have any questions about those, happy to more specifically talk about how they're tied to the OWASP top 10 list. So just to dive into one of them, which I think is really easy to understand, is security misconfigurations. And so here's an article from Ars Technica a couple weeks ago, or I guess a couple months ago now. But Netflix had account compromised because they didn't set one of their cookie configurations correct. And it's a really easy mistake to make. Kind of reading through the bug report, I'm like, oh, I've probably made that mistake in the past. And if Netflix can do it, even with all their security budget, any of us can. And so just to give a motivating example and dive a little bit more into what it means to write cookies securely, I don't have to tell all of you how hard it is to write secure code. If you're a student and you're working on a project, just trying to finish this before you can turn it in, probably not thinking about security. If you're a developer at a small startup like myself, you're probably just staying up late trying to ship the feature. If you're an AppSec professional who's protecting code for your developers, you have to put yourself in the shoes of the developers. It's difficult, right? And so that's why we all have jobs and why we need better tooling. So I was reading through the documentation for setting a cookie in a very popular Python web framework. This is Flask, but it's generally applicable to Django or Tornado or Java or Go or any framework. They all have a way of setting a cookie. But what surprised me is that the default options, there's a secure flag, that's false by default. HTTP only is false as well. Same site, it's kind of a newer property. But the default configuration is what you'd call insecure. And that surprised me. I'd call that almost like a gotcha. But this is kind of common throughout all the security literature. You have to go through and read in detail all the different API docs and all the sharp edges and these various tools and frameworks you can do, you're going to write with. And that's great, but nobody has time to read every single documentation, and it's always changing. So we need better tooling. So let's just look at how we would actually set a cookie. So this just boils down to a very simple example how you would set a cookie if you were reading a Stack Overflow post, or I'm just trying to I'm trying to just save the username of the user, right? It's a little bit of a toy example, but the concept is there. So I have a response object. I'm going to call setCookie on it. I'm going to give it a key, and I'm going to give it a value, and that's going to return. If I'm a security engineer, I'm putting my AppSec hat on, I'm going to look through and I want to audit all the places in the code base that one of the developers on my team has set a cookie. So how might I do that? Well, the easiest way and kind of what I would turn to first is grep, because it's very fast. I've used grep for many projects. I've used it since I was the beginning as a software engineer. It works across any language. And so just a first pass at trying to look for set cookies is really straightforward. It's response. You have to escape the dot. You have to escape the parenthesis. But it would look like something like this. But then I remember, if I'm a software engineer, putting on my developer hat, that there's many ways to do the same thing. And not all developers, are following the same tutorial, and the code doesn't always look the same way. So let's just consider 5 different ways we have to think about code if we're trying to write a grep pattern. So the first is sort of the naive base case, the response.setCookie that I've showed you. That's the default way you're going to set a cookie. But if I'm a developer, maybe I don't want to type so many characters. So oftentimes what you'll see someone do is they'll import it from Flask response setCookie. And then you might even shorten it if you're going to use this method a lot. So something like SC for setCookie. So if I'm trying to write that grep pattern, I can't just search for setCookie. I have to search for SC, and that's difficult because who knows what someone's going to call it. Maybe they just want to call it like sCookie or something like that. So maybe I could try to say, well, it has 2 string variables, or it's within a couple lines, or it's in the same file. there's various ways you could try to approach this problem with grep, but I think you'll see as we go through more examples, it's just difficult. So this one's a little bit specific to Python, but in Python, these keyword arguments where you say secure is true or path is some variable or whatever, the order doesn't matter. It gets converted to a dictionary. And so I can't just say like, oh, the last argument has to be secure is true or secure is false, because they could be anywhere in the string. So that's just another case I have to think about. Next, I use a formatter when I write Python. So typically I'll use black, where there's different auto formatters. And oftentimes what they'll do is they'll break this function onto multiple lines. And that is beneficial because then if I want to modify just one line, the diff's a little bit cleaner, it fits nicely on my screen. And so that's very common. And again, we're kind of hitting a sharp edge with grep, because typically grep by default only operates on a single line at a time. There is a global flag you can set, but now you have to write a more complex pattern, and you might have other unintended matches because you get these little bit of weird fragments kind of all throughout the page. And last, when I write code, I often will just be like, oh, this is not working, let me just comment it out. I might want to later, I don't want to have to search back through Git, so it's easy to just comment out the code. So now if I'm going to audit the code base, I might have lots of kind of false positives, as they're termed in the industry, where it's not really a problem because it's just it's not actually part of the code, but I'll have to think about that in my regex. So just to recap, they're kind of the different cases. We have the default case. We have these imports and renames we have to think about. We have keyword arguments to worry about, multi-line functions, and finally commented out code. So all that has to be in our mind when we're thinking about searching just a very simple case looking for someone setting a cookie. If we take the regex I wrote and I actually run it over these cases, I'll get 4 matches. You can see the one highlighted in green. It's pretty good, but I miss one case and I incorrectly flag a case where it's actually secure is true, same thing as secure, HTTP only is true, which is the best practice. So if you count these up, and for those who aren't familiar, typically you'll label them in one of four categories. If you've ever done anything with machine learning, this will be familiar to you, where you'll have a true positive, true negative, false negative, and you want to maximize the true positives and the true negatives and minimize false negatives and false positives. So this is 25% accurate, which is honestly about industry standard for a lot of tools. But I think we can do better. And if I'm looking through hundreds of these findings because I work at a large company, I don't want to have to go look through and get rid of 75% of them. And more importantly, and we'll talk about this towards the end of the talk, I would never want to show a developer, every four things I show the developer, they're 3 out of them, they're like, hey, go away, stop bothering me, this is not a real problem. So you just have to think about kind of what's the accuracy or the precision of your checks. I like this xkcd. If you have a hard problem and you throw regexes on top of it, usually you're just making it harder for yourself. When I go back and look at regexes I wrote 2-3 months ago, oftentimes I have to use some sort of online debugger just to understand what the heck it actually does. So what's kind of going on here is that there's a fundamental mismatch between what I'm searching for and what's actually important. So we write code as a string. We use Vim or Sublime or VS Code, pick your favorite editor. But what you're actually doing is you're programming a computer. And so every symbol you type has semantic meaning. And the computer has to understand and think about this. So for those who have maybe taken a compiler's class or have thought about a little bit more about how the computer actually interprets and executes these instructions, the first thing you'll do is usually parse it into a tree. And so the industry term for this is an abstract syntax tree. That's not that important, but you might hear me use the term AST. And that's just referring to this kind of structural meaning to the code, where you'll say, okay, yeah, there is a syntax for if something, else something, and that all has semantic meaning. And so I'm using a tool like grep, which is really designed for searching strings, and it's really powerful, but I'm trying to apply it to something that is a different structure in the case of code. So for those of you who've kind of thought about this problem or run into it in the past, you're like, yeah, why are you using grep? You really should be using a linter. There's great linter plugins out there that will be like, hey, don't set your cookie this way, don't eval your code, all kinds of different security issues. And a lot of them will even have direct mappings to the OWASP top 10 issues. Some of my favorite linters are like Node.js Scan, Bandit, Flake8, ESLint. Some of you may have even tried to write a plugin for one of these. They're all pretty much open source, and they'll have anywhere between say 10 and 100 different checks that come built in, and some of them are pluggable, so you can add new ones. One problem is if you are responsible for kind of maintaining multiple different languages at your company, even the smallest company, you're going to have a little bit of JavaScript, some backend language, maybe it's Python, Go, microservice. So you have to think about different tools and how you're going to cobble them together and be an expert in the syntax if you need to kind of tweak any of these tools. And so it's just a little bit of a barrier to learning. And I personally, when I'm thinking about searching for code, I'm much more likely to either open the code in like VS Code and just Command F and try to search for it, or I'm going to use grep because it's so much simpler to parse the code. To give you an example for those who've never tried to write a plugin, here's a very simple plugin that was looking for two kind of bad keywords in a Bo23 like Amazon client where there's a way you can basically hard code your password. And it took me about 100 lines of code where I have to basically walk over this whole tree structure, find all the call sites, look for all the banned keywords. It's some serious engineering work. It's a good plugin that I'm happy to have written, but it's not something I'm just going to like quickly pick up. There's also some commercial SaaS tools. Those are awesome. You'll probably hear more about those in other talks, but kind of for the sake of this, it's like expensive. If I'm a student, if I just want to work on something for my own project, oftentimes they're not something that's immediately available to me. I may not be able to even access the source code for these. I can't tweak the rules. It's hard to just sort of tune them. So love some commercial SaaS tools, but if you're just kind of getting started and you want quick answers, I think they're a little bit heavyweight. So you think about what we're actually trying to do here, like from an English level, language, like you're trying to tell your friend, what am I trying to search for? You're looking for all calls to Flask response set cookie. It's a particular method that you're concerned about, and you just want to find it. You don't really care how it's called or how it's, the details and the different semantic ways of writing it on multiple lines doesn't matter to you from the problem you're trying to accomplish. And so if I could express what I'm trying to look for like this, I'd be really happy. I need something that's somewhere in the middle in the complexity, something that's simple like grep, that has a little bit more power, like a proper, tool that can understand the semantic tree structure of code. And so that's where grep or sgrep fits in. It's in somewhere in the middle between grep and a proper code analysis tool. So sgrep, you basically can search code the way you write it. So this is an open source project. You can go brew install it right now. And if you've ever written a grep pattern, it will look fairly simple and easy to understand. So you'll do sgrep-e, which is where you kind of define the pattern. We'll say flask.response.setCookie. The only thing that's different than what I was talking about of how I would like to write it is you just do ... which is our ellipsis operator, which just says, hey, match anything here. I don't really care if there's 1 argument, 2 arguments, 5 arguments, 10 arguments. And then you give it a language, Python, and you just give it a path to the code. As I mentioned, it's free and open source, liberally licensed, so anyone can use it on any project they want. You can get started. The history of the project, it's not just some tool we kind of baked up in like 2 weeks. This has actually been around for 7 or 8 years. It was originally written by the first program analysis hire at Facebook, Yohan Petalu, who got his PhD in this stuff, and he worked on a tool called CoxML for refactoring and finding bugs in the Linux kernel. It originally was just supporting Hack and PHP, the main languages at Facebook, but in the last year since he's joined R2C, he's added several other languages and a bunch more nice features, including Boolean logic and things like that. So it's come a long way in the last year, and we have a long way it's going to go in the next year or two. But there's a rich history of really solid program analysis behind it. So to get started, you don't have to worry about writing this down because I think there's a link to the slide somewhere, but if you want to just remember something or try it out now, you can go to sgrep.dev, which is a simple redirect just to our GitHub repo. You can go start the project, follow it, try it out. There's a nice getting started instruction in the README. But yeah, that's the first part of sgrep. Maybe now, before we jump into how it works, we'll take a quick break here and let folks ask any questions. I think you just leave a message in the chat, and then one of the organizers will repeat the question. Ophelia, any questions, things I should wait for, or should we move on?
Chat seems pretty dead, so.
All right, that's great.
We'll keep going for now. Yeah.
We'll keep on trucking. So I'm going to just show you a quick tutorial of how we can write these patterns together. And we'll start out with a very simple kind of appset case. So maybe I have some Go code I've been working on, or one of the developers at my company has been working on, and I'm calling just the default server, which is HTTP listen and serve. And if you're not familiar with Go, there's additional methods, listen and serve, TLS, that will do the SSL encryption and kind of all the nice security features you'd expect from a production website. So we're going to just try to, again, audit our code base looking for listen and serve, and just go through and maybe manually review that. And I can show you this. So this is really easy to do on the command line. But for the sake of the demo, we also have a live editor, which is something like regex 101 or any kind of online code editor, which is just a little bit easier to get started. So I think that's coming through. If anyone can't see the live editor, just let me know. But to give you a quick overview of kind of what's going on here, because it's a pretty powerful tool, in the top left, we have a simple place where you're going to write a pattern. So this is where I'm going to search for whatever I'm looking for. And then right below that, I can choose whatever language I want to kind of look over. And then I'm going to go through and...
Hi, Drew. There's a question from the audience. He's asking if we can zoom in.
Yes, absolutely. Let's see, that might be a little bit too much. Is that better? Maybe I'll just readjust the screen a little bit. But as I was mentioning, there's a place where you can write what you're searching for. Excellent. And then below it, we're going to paste in some real code. So this is literally a hello world server. It's going to return back, it's a simple hello world website. And then on the right here, there'll be results that find if there are any results that I'm looking for. So just to remind you what we're trying to do here, we're going to go through and look for all calls to HTTP listen and serve. And I'm just going to scan this across my entire code base. So I'm just going to copy and paste code, and you'll see that a lot tonight. The main philosophy behind sgrep is that something you're trying to search for should look and feel like the way you'd actually write the code. So I don't know what other arguments someone might give it. I also don't necessarily know it's going to be served on port 80. So again, I've already kind of talked about this, but there is this ellipsis operator, this 3 dots that just says, just ignore everything inside the call. And I can just go here and just click run. It'll run half a second, maybe a little bit less. And you can see we found on line 15, yep, that's the call to HTTP listen and serve. So this is the most simple example, but I can already start to understand the power because I'm abstracting away calls to these different arguments. Jumping into the next tutorial, let's talk about a classic security issue where some developer kind of calls out to an exec function. This is like shelling out and doing something on the system. Maybe that's safe, maybe that's not. We want to kind of look for all different ways. So here I've made it a little bit more complex, but just giving basically, I guess that's 6 different ways you could call exec. 4 of them are things you want to basically audit, and then one's a comment and one's just in a string somewhere that, again, if I was writing a regular grep pattern, I might miss this. So again, it's going to be feel very similar to what the code actually looks like. So again, we'll call exec, and then I don't know the name of the variable, so I'll just do the same ellipsis operator, and I'll search that. And excellent, we've got the 4 cases we were hoping to catch, and we correctly did not flag the 2 cases that are false positives. Moving right along, this is a demo that's going to kind of show a case where you have injection. So for those who are kind of newer to the OWASP world, injection is, I think, the #2 cause of most security vulnerabilities. And you can think about it as just a user can control some part of your program. It's a file name, it might be a row in a database, some part of user data that they have control over. And that goes somewhere that is kind of dangerous. And so in this case, the user can control the file name because they can set that as part of the route. And then it's going to flow to this send file that's just going to read whatever that file name is off your disk and send it down to the user. So this might be totally legitimate if you're actually like, let's say you're having emails or something that you store on your server, blog posts, sounds reasonable. If it's, if I'm a clever attacker, I might go file name is ... all the way up and get a sensitive file somewhere on your server. So to kind of give you a real world tutorial of how we would search for this, I have copied that code below here. And so you can see it's really minimal, just importing from Flask, one route. We'll try to find that. So again, I'm going to try to write the pattern that looks and feels like the code I'm going to match. So I'm going to just copy and paste that in here and get started. Going through it line by line, the first thing, I really don't know what the developer is going to call the route. So I just want to abstract away the name of the route. So again, I'll use that 3.ellipsis operator. I also don't know what they're going to call the name of the function. So the first thing I'm going to do is just define a variable, call it $func. And this is the first time I've shown actually defining a variable. So what that means is you just do $, and then just some capital letters or numbers. And that just lets you say, just match any piece of code that kind of goes here and give it a name. You could almost think of it like a regex capture group or something like that. So the next thing I'm going to do is the variable I care about here, the user defined data, is this file name. So I'll give it $fn. And then oftentimes, just kind of this basic thing, you're going to have some print statements, some logging, some other functions that someone might call. But as a security person, that's kind of irrelevant to me. So I can just abstract away, one or zero or more kind of other statements that just says, just match anything in between there. What I care about is that it's a Flask method. It calls send file. And then I'm going to look for that same variable that I defined above. So $fn as the part that I actually care about. And then all the send as attachments, all the other kind of options that you can configure this function with, doesn't matter. So I'm just going to ignore that. And if we run it, let's see how we did. Great, we caught that. So this is a little bit more complex pattern. We're now writing using a variable, we're passing that variable to another function, we're abstracting away other statements inside the program. But you can see now how in just 4 lines or 5 lines, really easy to write, I can take something that looks and feels almost like real code and use it to match code. Cool, so let's go back to the original problem we had with cookies that we're trying to solve with grep. Just to refresh your memory, we're using response.setcookie, and we're trying to audit all cases of that. Now, I've already showed you how we could match this kind of in the command line with -e. If I go back real quick here, this is like the minimal thing you need to sort of audit the code base. But if you want to do a little bit better job, we will introduce this YAML syntax where you can start to compose these patterns. And this is really where a lot of the power comes out. So I've expanded the code that I'm trying to match to include a few of those tricky cases we talked about. We're mentioning grep. Here I'm importing the function and I'm renaming it. So that's something that's difficult to grep for. Here it's on multiple lines, and I even have this inner function that's going to generate the cookie value kind of programmatically. I've got a commented out code block. And then finally, I have the good case where I've set secure as true, HTTPs only, and same site. So if I want to actually go match this, the first thing I'm going to do is give it a friendly name. So I'll just call it like secure cookie, but you can name it anything you want. Then I'm going to think about kind of what's the logical operation I need to do to match this. So the first thing is let's ignore all the good cases. So we'll do flask.response.setCookie. And then I don't know what the arguments will necessarily be. So again, we'll use our ellipsis operator. And then we'll do, let's look for the flags we want to be set to be secure. So just type this out quickly. So let's just talk about this line for a second. Here we have the keyword argument, HTTP only is true. That means that JavaScript cannot read the cookie. It's only accessible kind of to the browser. And the secure flag means you won't send it over HTTP or non-encrypted connections. And that's how someone was able to sniff someone's Netflix account, because you're in the same Wi-Fi, you're at Starbucks, you're doing whatever, and the cookie just goes by in clear text. So by setting secure as true, you prevent that from happening. If you're paying close attention, you'll notice that the order doesn't matter here. So I have secure is true first, and then HTTP only. And here I've flipped the order. Won't matter because again, it operates at the like code level, where to the computer, the order doesn't matter. And then any other call to flask.response set cookie is suspicious, right? It may be fine. Maybe I haven't thought about my pattern enough, but I at least want to take a look at it and see what it is. And then writing any message you want, just be like, hey, cookies are hard. Talk to friendly security person. So you can give it anything you want here. And if you defined a variable above, like we did in the previous example, you can also use that and they'll get filled out with the code. But just think of that as a message that you want printed out on the command line when you're kind of searching through this. So if I've done this right, we'll see if we get a match. Excellent. We have the two cases we're looking for. Here we have the rename and the kind of the default way of writing it. We also correctly catch the multiple lines, but we are smart and we ignore the commented out code. And of course, we don't fire on the secure case, so I don't have to go look at all the good cases. And so that's an example of what it looks like to write a real rule using this tool. And maybe you're thinking, oh, that's awesome, but I don't usually write 27 lines of code on a web editor, and I don't want to paste my code in. How do I run this, kind of locally? Well, that's where it gets easy. So the thing you can do is you could copy and paste the YAML file into just any YAML file, and then you could just pass it in as a argument to the binary. You're installing it with Brew or Docker, but it's even easier than that. Maybe the first thing I want to do is I want to share this with my friend or one of my coworkers and let them kind of take a look at it. So I can click share and I get a little short URL that I can just copy and send that over Slack or email or any form of sending the URL. But if they actually want to go run it on real code, I say, hey, let's run it locally. I can pop in here and there's two simple ways of running it. You can use Docker. This just mounts the code inside the Docker folder, pulls the latest Docker image, and then gives it a config URL, which is that short link we talked about. And I can do the same thing with a binary if I've installed it through Brew on my system. The nice thing about Docker is I don't even have to install it. Docker will just pull the image. As long as I have Docker, that just works. But if you actually install the tool, then you can use the shorter command. So that's a way of like, okay, I'm going to prototype this thing out. I'm going to send it to my friend. Maybe they make some tweaks, send it back. Now I want to run it locally. How do I do that? Awesome. Now we'll pop outside the security domain real quickly because I want to show off another feature. Here we have some code. I'm a noob, so I'm checking to see if I log in and then I just want to exit and display an error. So if you want to basically exit the program in a state that's like this didn't work, usually you'll set an exit code of something that's non-zero. Exit 1 is pretty common. And this will work. This is totally valid code. This is a mistake that I made a couple months ago where most Python like interpreters have this built-in exit function that lets you kind of quit out, but it's actually not part of the language spec. And so the best practice is to use the system module, the sys module that will go through and actually call the system calls to actually make the exit, the program exit correctly. And so this is just a tiny little gotcha that is on the bitme that I thought was kind of fun. So I won't write the full pattern out here, but I'll just walk through it. So I have a case where I do call sys.exit. That's good. Here's the case where I just forgot to call sys. It still will work when I'm testing it out, but when I ship it up somewhere, a different interpreter may not have that built in, and so it'll cause an error. And I've got some nested functions and all that will work. The pattern's really simple. Again, I gave it a name. I gave it a simple pattern. I defined a variable $x, and then I went through and gave it a nice message with a link to the Stack Overflow, kind of for those who want it. But again, I don't want to have to go through and kind of manually fix all this. It'd be nice if I could get the tool to do some of the work for me. So I'm just going to go fix, and then I'll do sys.exit, and I'll do $x. So again, now it is able to reuse that variable that we defined earlier. And if I run it in this case, let's see, I'll have to make this a little bit smaller since I'm zoomed in. You get this new feature, which is this autofix suggestion. And you can see it's populated the variable where it will say, okay, sys.exit 3, sys.exit 4. If I just want to fix that, I can go click apply fix, and it just updates the code right there. I can say apply all of them because they all look good. If I need to tweak it, I can do that right there. And again, you can run this on the command line. So going back to that kind of run locally, just out of a config file. It will print out here the suggestion, and I think you can run it with like -a, and it will just apply that and modify the file. So that shows how you can actually use sgrep to find issues with your code really simply. It looks like code, and then you can go through and kind of provide the recommended fix. But I think the interesting part of sgrep is not these kind of simple cases, which you might already have another tool that's looking for, but oftentimes the security problems that are really devastating are the ones that no tool will catch because it requires human knowledge and human intuition of this application. So here we're going to talk through a quick financial trading app that for whatever reason, the way they've structured the security, every transaction must be verified before it's committed or made to the database. And so if you kind of read through the comments, you're like, okay, yep, basically there's this knowledge or this built up kind of organizational intuition of what has to happen. And so if you're a new developer, you might just forget this because who's got time to read every single comment? So again, you guys have seen me write a bunch of patterns, but I want to just quickly talk through first the code and then the pattern to show you how you can kind of match these very custom cases. So here's the code, here's the comment. The case that's good is I call verify transaction before I make it. Here I forgot to verify it. Here's a case where it's out of order. Here's a case where it's fine. Here's a case where it's also still bad. And then there's one case here that is actually we're missing. So you can see there's this test failure that's going on. We'll talk through the code or the pattern in just a second, but to give you the sneak peek, basically you're calling verify on some other transaction, not the one you're actually going to make. So that's just a classic, kind of placeholder for many common security problems. But let's look at the pattern, which hopefully is starting to look more familiar to folks. This is where I'm just looking for any call to make transaction where it doesn't happen to have a verify somewhere above it inside that same scope. There might be other statements around it, and I've just kind of abstracted all that away. But if we look at the case where we were having a problem, it's because that the value that's passed to these two different functions is different. And that makes total sense why we're not catching it, because we're saying, oh yeah, well, it did get called verify with whatever, and then we called made. So that's not a problem, but it is a problem. And so I'm just going to now give it a real equality between the two. And I'm going to give it a quick variable $T for transaction, and whatever you want. And now if I run it, I'll see that all the tests pass, that I've kind of gone through and commented out, hey, it should find here, we've caught that correct case where someone has a different variable. So that's, what is that, 15, 20 lines of patterns, but it's really just two simple patterns that you're combining together and using a variable to look for this really kind of interesting gotcha that only the person who's deeply familiar with that code base could think about and write. One last example I'll show you. This is really just having fun. If you think about it, would a developer ever call something like if foo is equal to foo? Naively, that's always true because you're comparing something to itself. And so that's usually probably a bug, or it's certainly never going to execute the else case. So as you can imagine, kind of in your head, how would I write a pattern that would look like this? It's going to look very similar to the code that I'm actually looking for. If you haven't guessed it already, I'm going to do $x equal to $x. And in this trivial case, yes, it caught it. Great. But of course, the real world is messier than this. So I actually want to go search a real get project. This is a thing here. I'll just quickly sign in. So this is a little bit more of an advanced feature, but this lets us go through and scan real Git repos. So I've signed in here. It's a very kind of messy page, but to give you a high level, you can just paste in any Git URL and scan it. You can look at your own projects here and say, oh, I want to scan this one. I'll just click that and I can scan my own project. And then I can see the history of the scans I've done. But I'm just going to go through and search the Apache libcloud project, which is a pretty popular, almost cloud abstraction layer that people will often use. And let's scan that. Take a second or two, scans it in real time. And if I look into it, I've done this before, but for looking at it the first time, I was surprised to see that there's a case where someone's basically said x equals to x in this cloud driver for Cloud Sigma. So let's go take a look at that and see if we found a real bug or not. So this is like a 2,000 line file. You know, I've read through it before, and I think this is a real bug. If I just zoom in real quick here so you can see, there's this internal method that's going to get a node. And the node is probably some service in a cloud provider. But you can think of it as like, I just want to get the one node that I care about. And there's a self method, and there's this node ID. So I'm going to get all the nodes, and then I'm going to filter through it and find the nodes where the node ID is equal to the node ID, except it's, you know, basically the bug. I think the developer intended to say if node ID equals node underscore ID, but maybe their editor just auto-completed this, or they retired or something. So in this case, I think it's a bug that will return back all the nodes, and then you'll grab just the first one. It'll be a random node, not the node you'd expect. So I should probably go file a bug report afterwards, after the talk, but that's just an example of using a really simple pattern and then running it on some real projects. You can actually find some bugs. So yeah, just jumping back into the presentation, and I'll take a break here for questions on the next slide. But you're probably thinking to yourself, you really expect me to write all my own rules? It's super exhausting. I'm at home, I'm busy, I've got a job, I'm a student. There's got to be some way that I can reuse the work that others have done. But before we jump into that, I'll just pause and talk about, take any questions.
Hey, Drew, it's Yukve here. I actually do have a question. Would it be possible to go back to the send file example?
Absolutely. This one, yes. Do you want me to pop into the live editor or just talk about it at code level? Sure. Okay, actually, I'm going to jump right to the solution, which I linked for folks who don't want to have to write the rule themselves. Cool. Yes.
Right. So would this catch a case where the file name variable was somehow renamed within the function, and then send file is called on that second variable name?
It should, and we'd like to get more there. It really depends on the is it a constant or not? So in certain languages like Go and C and JavaScript, there's these constant keywords, and then it will, because it can actually track oh, this is the same thing. When you get into some of the variable renames, you get a little bit trickier. And so we're working on some taint analysis that I'll talk about, kind of the upcoming roadmap that will do that properly. But right now, what I found is just in practice, you just write a really simple pattern, find the 20 cases, look through the 3 that are oh, actually, that's not a problem, whitelist those, and then keep going. And so I think, I'm trying to, I guess, think about when I write my code is how do I keep it simple? How do I not have lots of, complex variables that are going between different functions, but keep the sort of the scope right near where the problem is happening. And so in that case, then it works really well in practice.
Okay.
But yeah, good question, and we can talk more about kind of the taint analysis engine at the end.
Awesome. Question from the audience: any ETA for PHP or TS support?
PHP is actually supposedly a day away. It's been kind of forgotten since the original author left Facebook, but he's yeah, I can add PHP whenever I want to, because that was what the tool was originally built. Before, you just have to update to some of the newer PHP syntax. So that could come really quickly. And then TypeScript is a language we're actively working on along with Ruby and Scala, because those are languages that we use. All of our front-end code, everything you see here on the live editor is written in TypeScript. It does work, kind of out of the box, but it's not as well supported as just native JavaScript right now.
Thank you.
Yeah, absolutely. Any other questions, or else I'll just save questions for the end.
I don't see any questions from the chat right now. So how about we continue and then save questions until the end?
Perfect. All right, so Homestretch here. Let's talk about part 2. If you want to use this tool yourself, as I mentioned, you can just go. It's free. It's open source. Run it with brew install, and then you can pass it a config. And this can take just a YAML file or a folder of YAML files. So very flexible and easy to get started. As we started writing rules, we were hey, we want to start collecting these rules in a place that is open and let other people contribute and use these rules. So we have a sgrep rules repo that's open source, and I can just give you a quick demo. it's organized by language and kind of subgroups. So we have Go, C, Java, JavaScript, Python. If I jump into like Python, we've got a whole bunch of different things here like certificates. And so then you can look in and see, okay, if I want to look for like disabled certificates, someone's gone through and figured out all the different ways you can kind of turn off certificates in like URL lib3 or these different kind of certificate requesters. So that's an example where I can just then copy paste that into my config and run it. And it's very easy to do. And what I was going to also mention is that we're getting some great community participation. So we've got about 250 rules in that project. We've written about 80% of those, but the author of Node.js Scan, which is one of the most popular tools for JavaScript, has ported about 90% of his rules. And we're getting rule ideas from like the core teams at Django and Flask and a bunch of different independent security researchers who are like, hey, it'd be interesting to search for that. And they'll either write a rule or they'll kind of tweet at us or something like, hey, how would I do this? And then I'll go write the rule. So all the rules are going to live in this repo, and anyone can use them, run them on any of their projects without having to pay us anything like that. And just to give you an example of a rule that I was working on, or never would have thought of originally, somebody else on our team who was more of an expert in this part of the code understood, the dangers around these JWT tokens, which are these like basically web authentication, almost like driver's license. If you're going to go around the web and interact with these different websites, you can get these pretty nasty vulnerabilities where the attacker can say the security algorithm is none, which means there's no encryption, there's no verification. And I think like Auth0 was just bit by this bug a couple weeks ago. And so there's just like many different ways you can set the algorithm to none. And so somebody who's more of an expert in this, they can contribute their knowledge and say, oh, I know about this. And I don't have to be an expert in exactly how these JWT tokens work because they're part of this community registry. The other thing that we do with our community registry is we run them across this like 5,000 machine parallelized MapReduce that runs in the cloud. And we'll run that every night and just kind of look through the rules, start to triage them, label them, get an understanding of like, hey, is this rule performant? Is it good? Is it correct? Are there lots of false positives? Are there false negatives? And that's something that we think is really important because typically people kind of think of static analysis as really powerful, but super noisy and almost not worth the time. So this runs in the cloud. Probably looks something like the data center on the right, but I like to think of it more like that. And when we ran that simple rule that I was showing earlier, the $x equals $x at scale, we ran it over a couple thousand Git repos, we quickly realized that there are some cases where this is true. It's typically a shorthand in like test code, or someone wants to comment something else, they'll just do like 1 = 1. It's kind of an idiom. Maybe it's not the best practice, but we're like, well, we want to tune the rule. And so we went through, I think 3 or 4 iterations to get like 99% true positive rate. And the full pattern looks like this. It has a really nice message. It tells you that actually like equals is the same as not equals, because that'll always be false. And give it a language and give it a severity. So we ran that. We found some real bugs. We're talking to the different groups to get those fixed. But this is what I'd call like a verified rule. And so that's what a lot of our effort this month and next month is taking all those community rules people have written, kind of scoring them, figuring out which ones are good, and then tagging them as verified. So if you're interested in more and you'd like to help us kind of beta test that, there's I think a link at the end of the survey, or just send me a message or send me an email, and we'll help to get you added to our beta test for these rules. And if you're like, oh, I love it, this is awesome, I want to start using it immediately, what does that look like? Well, you can find bugs in code. We've been doing that for the last 30 minutes. If you get CVEs, that's awesome. We'd love to send us a message if you actually get a CVE with this tool. We're kind of collecting a trophy case of CVEs we found internally, and we'll be releasing that shortly. But really, like as application security engineers who are responsible for securing web apps, like what you care about is like secure defaults, secure frameworks. You want to get them like as close to when the developer makes a mistake, so you can kind of jump in and understand if it's a real bug or not. And so you want to set this up as part of your CI/CD pipeline. So we've made it super easy to integrate with pretty much any CI system. We have an official Docker image. We also have a Linux binary. We have JSON output. We use Circle CI a lot. So this is just like 10 lines of Circle CI code. Use the Docker image, and it works quite well. You can see here I'm writing some Django rules. And we also have a GitHub action that we've put a fair bit of thought into, because you don't want to just find issues anywhere in the code base. The developers can actually like submit a pull request. You want to kind of do the diff, and that's a little bit tricky to get that right. But you want to sort of show, hey, here's the issues in the code you're writing right now, and make a comment on the pull request. So we have a GitHub action that I encourage folks to talk to me about if you'd like to get help setting that up. And then just I want to zoom out for a second and talk about where we're at. Is this security and developers and kind of where the industry is moving. So I think this is a really exciting time to be an application security person. If you think about like the surface area of things you have to protect as just a generic security person, you've got the network, you have identity and passwords and all that stuff. A lot of that people are moving to the cloud, or they're putting two-factor in and eliminating kind of whole classes of vulnerabilities. But what's definitely not going away is that developers are writing more code than ever, and we need to think about how we secure it. So I'm not affiliated with any of these organizations, but I think Snyk's done a really good job of making it super easy for developers to find vulnerabilities in third-party software. And then earlier today, I was really excited to see the work that GitHub is doing with their new security lab and some of their code scanning features and their security tab. So I think this is like the sort of the next wave in security. If you're thinking about getting involved in code security, I think it's going to be a really great time. And one thing that's neat too now is we actually have the tap points and the tools to communicate with developers. It's no longer this walled garden where security scans code, and then 3 months later developers like, hey, why are you telling me there's a bug? I've already moved on to a different project. We can be in the editor. There's rich support for diffs and file editors and tools like VS Code. You can be right in at the pull request. A lot of people now have continuous integration, which used to be something that only large companies like Google and Amazon and others had, but that's now best practice. So I think there's a lot of really great tap points for application security. We talked about some features coming soon, so we're working on some more code equivalences. This is things like $x plus y is the same as y plus x, the commutative property. That's true in 99% of languages. So there's a way you can actually define your own equivalences as part of that YAML syntax. And we're building up this this registry of different code equivalences. So like, for example, opening a file, you might do file open, you might do path open, you might do with open. They all mean semantically the same thing to a human. The next thing we're doing is we're adding in support for external typers. So languages like Ruby, TypeScript is a great example for JavaScript. You have MyPy and other optional typing for Python now. And so you can write more precise rules by saying, well, I only care about it if it's an integer or a string, right? So we don't want to do all the work of understanding the types, but we're happy to kind of call out to a third-party typer and get that information and bring it back in. And then the next thing kind of extension to this is the taint analysis. So if you think about what is a user data, well, it's just special type, it's user data, and then it flows through the program. And then if it is still user data, it's not a cleaned user data or a safe user data type, when it actually enters the program, then that's a security issue. And so we've been putting a lot of energy into our taint analysis engine. And that's something that most commercial products have as well. But again, it's just an open project on GitHub. So go start the repo, kind of follow along. We've got a couple milestones we're working towards, and I expect these features will ship over the summer. That's the bulk of the talk. Thanks so much for paying attention and learning along with me. We have a bunch of rules that are specific for OWASP top 10 issues. If you're interested in those, you can go check them out in our repo, but it might be easier to just fill out our survey. We'll send you a direct link to some of the rules we think are the best, and you can get started with those right away. So yeah, check out our survey. I'd really appreciate any feedback you have on my talk. May the 6th be with you.
Thank you. We do have one other question about from Xavier saying, is checking config files like YAML part of the plan?
Yes, and actually I think like going back to the security misconfiguration, so much of the way you actually deploy a service is through like a JSON configuration, say CloudFormation templates, or we use Terraform. And so being able to parse all those different configuration languages, I think has an outsized return from the security side of things.
Awesome. There's a couple people in here that just are thanking you for a great talk. Any other questions from the audience, comments?
Yeah, if you have a question you maybe don't want to ask in this kind of forum, feel free to email me or follow me on Twitter. I've had a lot of fun building this over the last couple of months, and releasing it. And we're looking forward to all the feedback and seeing what people use it in new ways and find new issues. Together, I think we can find really interesting security bugs and help protect really important software.
Agree. Thanks, Drew.
Thanks,
I'll
everybody.
give you guys a couple more minutes to think about it, but so I'll give you some closing notes. So again, there's the 2 feedback forms that are sitting in the description of this video. One is the feedback form for the OWASP Toronto group, where we ask you about things like the future topics that you're interested in, how you found these events. Reminder that if you want CPE credits and we need to be able to say that you were at an event, please fill out that form so that we have your email address and we can say, yeah, this person was here. And then the RTC form to get in touch with Drew. And then I just want to quickly thank our sponsors because they do keep us live and able to do this. So that would be Security Compass, HP, Checkmarks, Amazon, Shopify, and Sonatype. And then the last reminder is that we have another event on May 20th. So we'll see you guys then to talk about brand new software security initiatives and how to start them. And we'll be sending that info out soon. So thanks again. We'll be here for another 5-10 minutes just to see if you guys have any closing questions. And then we'll see you again later. Thanks, guys.
Thanks, everyone, for letting me present. It was a lot of fun.